Okay, welcome everyone. Welcome to the VDK community meeting for September 2023. The agenda for today, as usual, I'll go quickly and we'll make a quick intro of VDK, basically for the people that are not familiar with the project in general. And then we'll jump into the agenda that today will be the latest release announcement. Antonio will do that and will tell us what are the latest stuff in VDK, and will give us a few more updates around those. Also, Andy will talk about the support of multiple Python versions in VDK, how we do this, and we'll make also a short demo around this new feature. And finally, Dylan will talk a bit about the currently running initiative that we have in the project, which is related to the VDK Run Logs, basically to make them more readable and more simplified for the users. Okay, so let's get started. Basically, a short overview of Versatile Data Kit. It is an open source project that my team is basically supporting and moving forward. You can find it in this is our repo, more or less, and in one short sentence, what does VDK means? This is just one framework to develop, deploy, and operate the data workflows with Python and SQL. Basically, this project more or less is actually is built out of two sub-project. One is VDK SDK, and the other is the control service that handle different pieces of these tasks of VDK. In the latest months, actually, we updated quite a bit our repo and the main README, especially with the introduction videos about what is SDK, basically jumping on all the big pieces that VDK supports, like data ingestion, data transformation, the deployment of the data jobs, and after that with the operations and monitoring. If you are not familiar with those, highly recommend to go over these really 30-second videos and double check how we do the stuff. And finally, one thing to mention is that VDK is a project that is highly extendable. So basically, every piece of the product more or less is extendable with extensible with plugins, including the control service, including the SDK, etc. And finally, like a call for action, guys. If you are interested in contributing to the project, you can always find us. With these contacts, you can file feature requests and stuff like that. And of course, you can directly make a pull request if you think something you want to change makes sense, and we'll come and discuss it with you. Okay, with that short intro, sorry, guys, let's move to the first topic about the latest release. And Antoni, do you want to share the screen?
Yeah, please. Okay.
Cool.
Oh, wow. Yeah, our style data kit has a different components. So the release is a general release announcement, what we've done in the last month, what has been developed in the open source project. The VDK SDK has the following improvements. The first one is the new CLI command called SQL query. It's currently experimental, so it's hidden. But if you type a VDK SQL query, you can execute any query which is managed by VDK. Until now, there were actually this kind of database, like in Power Query or Trino Query commands, which were added almost entirely for development and testing purposes, but they were found useful. So now we've created dedicated command that can be used for any database. So for example, like in this case, let's say that we wanna use Trino. We can execute VDK SQL query and SQL query, and the output will be shown. Or if you want, we can do this in JSON format with minus output JSON, and then the output in JSON format. This is just for quick testing prototyping purposes. It's the next thing is around VDK notebook integration, which is basically how the release is being done. You can find one here is getting started, which explains how you can use it. What exactly is a data job? Explained through notebook. How you can log in if you need to. How you create a data job interactively, visually. How you can download data job if it exists. And how you can develop it. Explanation of different types of steps and how does a notebook data job looks like. Basically, data job is a sequence of cells, right? Steps. You can reuse job input.
ازيك يا قطة عاملة ايه؟
الحمد لله اليوم كلها وانتم
وانت
بخير.
بصحة وسعادة يا رب، ربنا يحفظك ويلاقيكي دايما.
Somebody, got unmuted by accident. Oh, that's right. That's an example of data job. You execute query. You can mark different cells as ready VDK cells, which means those are cells that you want to deploy in production, and testing cells, which don't have VDK tag. And in the end, you can run the data job to test it and deploy it. This is all showing this getting started, which is very visual. The other improvement is until now, the way you execute SQL query in Notebook, for example, was using this kind of Kubernetes way job input execute query, and the output was shown like this, which was not very user-friendly and easy to do. With VDK SQL Notebook cells, now all you need to do is just type %% VDK SQL, and then you just enter your SQL statement or SQL query, and the output is exposed as a widget, which allows you to, this is using IPGrid widget library, which allows you to search. You can see the column names and the data types, search about the data and the attributes, allowing you much easier data exploration and understanding of the data while developing data jobs. This is like when you one of the common issues when you're troubleshooting any kind of data ingestion transformation workload, is you need to be able to visualize the data after certain step, and this will make it easier. Then I will mention more. This is primarily relevant for plugin developers and not directly for VDK users. But VDK is deprecating the use of walk and retrieval pattern or walk and throw patterns in favor of report and throw. So basically means that the idea is that we've shown that the VDK walks can be extremely verbose and walking the same thing more than once. And this is one of the improvements that aims to reduce that. And currently, there are other ones that are planned, but this one that was implemented this month. and some improvements in the control service, which is the part which takes care of running jobs and operations and monitoring them. This is primarily for operators of VDK who wants to deploy and manage control service. When they do, they one property for security authentication without ways being deprecated in favor of allowing to be able to specify multiple issuers. The idea is to enable to switch more gracefully between different authentication providers. Another security update that was done basically by the VMware team was where style dedicated control service enables webhook APIs, both for authorization and also for some post creation or post deletion of a job extensibility. Until now, they were using the same token as the user does. A new way for authentication was introduced, which would allow system administrators to specify a specific system token to be used instead of user token, which may have bigger privileges than the user. And you can find all the changes listed. I've extracted only one that I think were major features, but you can find all the details for the changes that were listed in the what's change part of the release. Oh, cool. I think that was everything from me.
Okay, thanks. So next topic is about multiple Python version support. Andy?
Okay. Hello, folks. So this presentation will be more suitable for administrators, not so much for end users, but I'll try to cover all bases. So, and the demo also shows the user perspective and what users can expect. So let's begin. With today's presentation, I'll talk why we needed to support multiple Python versions, what options we explored, and some implementation details as to how the control service now operates with the support for multiple Python versions. So we had a few main issues when we supported only one Python version, and these were that when a client decides to use libraries or some third-party packages that were not supported by the Python version that's deployed with the control service, this led to data job deployment failures, unexpected behavior, if in cases the packages were actually installed, there were platform errors and those sorts of unexpected things. Also, if we wanted to test something on a specific Python version, the process was complex. We had to have testing deployments of the control service and all other components that were identical to the production, and this requires more resources. So with this support of multiple Python versions, we could just add a new Python version, test whatever we needed, and then if everything works, we can just switch the default. So it was much seamless and we could cover more edge cases. And yeah, that's probably the final main issue we had, that if we decided to switch the default Python version to be something new, for example, to go from Python 3.7 or 3.8 to Python 3.9, 3.10, that meant breaking changes, redeploying old data jobs again and again, and all sorts of other issues and downtime, which was not something that our clients wanted. So yeah, this is why we needed to support multiple Python versions. And the options we explored were basically either because the control service is deployed through a Helm chart, everything needs to go in the Helm chart. And we had a few things that we could do there. We could either have separate Python version for all options that we supported, and also we could have different environment variables with templates that would basically build the final URIs for the images that would be deployed when a data job is deployed. And these were requiring a lot of boilerplate code, and were unnecessarily complicated. So we also thought about having config.ini that is deployed alongside the control service. That also covers the different Python versions that are supported for different VDK images and data job based images. And this was kind of cleaner, but still it required again additional logic in the control service that would parse everything and would we would have to keep track of what is used where. So the option that we chose, and that seemed to be the cleanest one, was to have a map in the values YAML file of the control service Helm chart with the versions that are supported and the associated base images, VDK images, job builder images, etc. And this way we could cleanly load the whole configuration at once. No additional parsing was needed or anything that would make the system more complex and probably lead to other problems down the line. And yeah, this is what we chose. And this is basically how we implemented it. In the values YAML file, we have only one map with the Python versions and images. For the API, we needed only to expose one property, essentially the Python version that's to be used. And this is basically what the users would use, the end users use, in the sense that for when a data job is deployed, the Python version is the only thing that needs to be specified in the config.ini file. And the rest of the operations are taken care of by the control service. We have everything in the image registry. The control service manages the deployments. So there's nothing more complicated for the end users, and for the administrators, everything is in one place in the values YAML file. So it's easy to keep track of what is available, what's used, and where to find it. Also for the users, they have an option to see what Python versions are supported through the VDK CLI. The command is VDK info with the team name of the user, and they can get information for the supported Python versions. They can choose which one they want and effectively deploy their jobs with the Python version they need. So for a demo, I have a pre-recorded demo, as it takes some time to deploy the Helm chart and the associated data jobs. And this demo is, I've tried to make it as concise as possible and cover the end-to-end cycle without the need to wait. So this for the demo, I use the VDK server that is installed when you install Quick Start VDK. So it provides, it requires kind to be pre-installed, so it can start a local Kubernetes cluster. And as can be seen in the demo, I have prepared, maybe I can make it a bit larger. Okay, so for the demo, I have prepared values file that where I have added the additional configuration. Most of it is just some defaults. The important part is the deployment supported Python versions configuration with the images. Basically, we have a base image for the data job base that is used when the data job is deployed. We have a VDK image specified, which is the VDK version, basically the VDK distribution that is used by the job when it's deployed, and a builder image in case we have a specific job builder configuration that we need for certain jobs. In general, probably only one builder image is needed because it covers most cases, but if you need to have some security, if you have some security constraints, then you may need to prepare a builder distribution which is which has less privileges and allows and limits the final job of doing things that are not that may be considered a security concern. So yeah, when we have the values file with the configuration that we need, we can just do Helm upgrade, and this will basically update the Helm chart. The new configuration will be merged, and we'll support multiple Python versions. For the purpose of the demo, I've created 2 data jobs, which are basically the same job. I mean, the data job code is the same, so there's nothing special in them. I'll just show how we can specify different Python version for the different jobs. The first one would use the default, so there will be nothing to do. If we are okay with using the default data with the default Python version, then it's basically set, so the job can only needs to be deployed and to be fine. For when we need a different job, a different Python version, then we need to add the Python version property to the config.ini file of the data job. I'll show this in here. Basically, the Python version property needs to be set in the job section of the config.ini file. Otherwise, it will not be, it will be ignored, basically. So that's not something we want. And yeah, when we do a deploy show of a data job, we can see what Python version the data job is deployed with. And yeah, that's basically it. Everything is set as properties to the cron jobs and labels. So administrators can have access to what job is deployed with what version and image. And that's it, I think. I'm not sure if I have anything else to show. Also, yes, I've added links to the additional materials. Basically, there is a example in the VDK repo. In the examples, directory with a complete walkthrough of how to deploy a control service with the support for multiple Python versions, and also how to deploy data jobs by choosing a specific version. And if we look at the deployment of the service, the Python version, the default Python version, and the support Python versions are set as environment variables. So they can also be examined for operations purposes if that's necessary. And that's all. Any questions? Comments?
Not from my side, thank you.
Thanks.
Cool. Thanks, Andy. I believe we can move to the next topic, which will be a quick overview that Dylan will give us for the VDK Run Logs Initiative. Dylan?
All right. Let me share screen and go to the correct thing. All right, yeah, so the VDK Run Logs Initiative, basically what we did is we gathered a bunch of user feedback, and we had maybe two main takeaways from it. Is one, that when a data job fails, the errors are too, like, they're very verbose, and it's not very easy to get necessary information to fix the error from the error itself, just because they have a specific format, and they're also sometimes nested within each other, which is even more confusing. So there's also, like, the formats and the API that we have also incentivize some bad practices, like people would just, when throwing an exception or when using our API, they would add some generic information like an exception occurred, which is it's fine to do maybe once, but if it goes up the call stack and there's a lot of those, it kind of it builds up. So this was one takeaway, and the other takeaway is that people actually told us that when when they have a data job which is successful, they rarely, if ever, read the logs, and this will become important later. So as far as error handling goes, I mean, I have some logs from failing data job, and I'll show you what the experience looks like. You get this kind of error message here, and you can see in here it's repeated with basically the same information. And how should I put it? It's also nested. I don't know if you can tell that, but it's kind of annoying to actually read the same thing over and over again, where maybe you just need to read this once and then look at the stack trace, which is completely fine. But if you come to the end here, then you have to scroll up and then just read everything, which is it's a bit confusing. The other the other piece of feedback we got, that our error classification is actually pretty good. So when an error occurs, we know who should solve it. In this case, like for this log, it should be the user. So this is something that we should keep. So based on this, we started our Run Logs initiative, and we did some more analysis, and we split our split the initiative into 4 work streams, which in no particular order, if I can get the table of contents, are like log structure, log list, clean error handling, and progress indicators. So we're currently working on clean error handling, and what this means is it means that I should fix my links. But yeah, what clean error handling means is we want to, okay, so the reason what I showed you actually happens is that our logging API in VDK core is coupled to our error reporting API. And by error reporting, it's also called error classification. So when an error happens, we need to know who should fix it, whether it's the user, or in case of cloud deployments, whether it's the platform team. So we need to keep this, it was coupled to our logging API. So you would have something like log the error and then classify it, and they're coupled. So if I want to just classify the error, I have no option but to log it as well. And you can actually see how this is, it's sort of a problem, just because you end up repeating the same thing over and over again, and just bloating the error message, which is not good. So this initiative, it's basically, this work stream for clean error handling, it means that we should split those 2 APIs and then survey our logs and find out if, hey, maybe we need to log this here, or maybe we don't need to log it, and just shorten our error messages. Same thing goes for classifications. So there may be places where we're classifying errors, but we should be just logging them. And yeah, this is what it means for a work stream. And based on the other takeaway, we have another work stream that's called progress indicators. So as I mentioned initially, based on user feedback, we got people rarely, if ever, at least for local runs, look at the logs if everything is successful. Even if everything is successful, they will still get this verbose logging status. And on the flip side, if there is an error, they get to read this wonderful thing, which it's not ideal. So this is actually the worst of both worlds. And the thing we described here in our VP is that we want to add progress indicators, which would basically mean that when you run a data job, you will have the option to pass a flag and not see all these logs, and just see like a progress bar loading. And if everything is successful, then your progress bar will finish, and there will be that. If there's an error, you'll get some kind of generic message and then be referred to an output file, let's say, or logging file. And it's kind of similar to what a lot of these command line tools do these days, with npm being being a prime example of that. And we believe that this will significantly improve the user experience for local runs. And again, on the flip side, you can have this verbose status in the cloud if you want, or you can have it locally. We'll just give the option to pass a flag and choose between the two. Okay. The third work stream I want to talk about is log structure. So we want to empower users to actually be able to choose the metadata that they log, and how their log messages, or like what their log messages look like. So for example, the idea is that locally or in the cloud or wherever, you would pass something like array in your data job config if you're doing it locally, or in the global config if you're doing it in the cloud. And you would be able to choose something like, okay, I want to see the VDK tag. I don't want to see this timestamp. I want to see something like I want to see the file and maybe the data job step that this is coming from, and that's all I want to see. So the idea is you pass something like this, and you'll be able to actually choose the metadata that's logged here. And the other thing that we want to do is, right now, it's not really a problem, but it would be nice if we could switch between this kind of format and maybe a machine readable format for logs. So we want to also introduce an option to choose your own formatter, let's say. So if you want regular logs, you can choose the regular formatter, but maybe for cloud deployments, you can choose a JSON formatter or some kind of key value formatter or something like that, which will completely change the way that this looks, and maybe it becomes machine parsable, and it will help your analytics. Yeah, so this is the third work stream that we're doing, and the fourth one we've cheekily named Logless, which is, I think, the last one that we're going to work on. And basically, after all of this is in place, we can go over our logs and figure out if stuff's at the appropriate level, if we have something that's repeating, if there are error messages we would like to eliminate. We will be able to do it because our APIs will be separate, and we will touch, I think, fewer use cases this way once everything else is in place. So yeah, you can, like, this whole initiative is transparent, and you can read about this in our VEP, which, I mean, it's still work in progress, but it has a bunch of information in there. And it's also broken down into milestones that you can look at on GitHub. So, for example, for clean error handling, you can see that there are still some pending tasks, but it's 41% complete. You can also look at our timelines. I think those are, or like at our roadmap, I think this is public too, right? And you can see initiatives here, and what we're currently working on. So yeah, I think that's it. Questions?
I guess no questions. Dylan, thanks a lot for sharing this with us. Maybe I can share my screen. Okay, cool. I believe this is all that we wanted to talk about in our agenda today. Our next community meeting will be end of October, so 25th of October, the same time, the same place. Basically, the topic for the next community meeting we'll share it maybe after 1 or 2 weeks, and we'll get prepared for it. And I guess that's it. Thanks a lot for coming today. And if you like our project, guys, please give us a star. It helps a lot more than you can imagine. But generally, if you would like to connect with us to try the project, please do. You can find us as usual on all the channels for support and contribution, and also for contacts. And thanks. See you. Bye.
Thank you very much. Have a good one.
Bye bye.